Hi, my name is Jessica Dean, and I'm a senior cloud advocate at Microsoft. I'm super excited to be here today to hang out and talk about developing with confidence, even in an abstracted world. Now, let's just dive right in. What is DevOps? And as it turns out, you could actually ask 5 different people what DevOps is, and you'll probably get 5 different answers. But at Microsoft, DevOps actually means something incredibly specific. In fact, this quote was written by Donovan Brown. There's a little Dono dude in the bottom right-hand corner there. And he spent 30 days to come up with this quote because every single word on this slide is important. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. Continuous delivery of value. The most important word on this slide is value. Because if you're not delivering value, what are you doing and why are you doing it? And more importantly, how do you know if you're delivering value, right? How can you tell? Do you have metrics? Do you have insights? Do you have telemetry? And notice I didn't say continuously deliver code or continuously deliver features. Because if those features or that code isn't valuable to your customers, what's really the point? So the end goal for DevOps is to continuously deliver value. Now you might be wondering, why exactly is this so important? Why do we keep harping on the definition of DevOps and talking about value? I am so glad you asked, because especially in today's time, a remote world, a pandemic, the bottom line is the speed of business is moving so incredibly fast. And the only way dev teams can keep up is if they adopt DevOps best practices and adopt a DevOps mindset. If they don't, they will be left behind. And here's the sad truth. If you don't adopt DevOps best practices now, your competitors, they either already have or they will. And once they do, here's a really sad truth, they will out-innovate you. And when that happens, you will become obsolete. And real talk, no one wants to be obsolete or left behind. Now, why do I bring this up? Why do I have this heavy moment for a keynote, right? Well, the answer is actually easy. Because this right here, this obsolete and left behind position, is the exact position Microsoft found themselves in around the 2000-2010 timeframe. Back then, we were still delivering code once every 3 to 4 years. But our competitors were innovating faster. And honestly, we were losing customers. Now, for obvious reasons, this was an incredibly scary place for us to be in. And we knew that we had to change. We knew we had to adapt, we had to shift, we had to adopt the DevOps best practices. However, this was also a very difficult thing to do, especially in a global company. And one of the lessons that we had to learn is this. If it hurts, you have to do it more often. You see, we're all human. And when things hurt, we have a tendency to avoid them, right? That's just honestly basic human nature. We don't want to do something that hurts. And what really hurt for us here at Microsoft was pressing that deploy button. Because what would happen? Every time we pressed that deploy button, guess what? Things would break. And naturally, what did we do? We wanted to avoid it. So let's say that I had some changes to make to our application. Maybe I had 40 to 50 lines of code to check in. I would intentionally avoid deploying by saying that I wanted to wait until the end of the sprint, right? Let's just wait until the end of the sprint. Because I knew that if I pressed deploy, things were going to break. And it would turn into a big, painful headache. Eventually, though, what happened? We pushed the deployment even further. Rather than the end of the sprint, we would say, you know what? Actually, let's deploy at the end of the month. Or maybe let's wait until the end of 6 months. And if we're incredibly honest with ourselves and with each other, chances are it's probably going to get pushed out until the end of the year. Now, what was once just 50 lines of code is now thousands upon thousands of lines of code. So of course, if we try to take all that code now and push it into production, that just makes everything so much worse. And of course, things are destined to break. That's why this slide right here was an incredibly important lesson for us to learn. You see, if it hurts, don't avoid it. Do it more. Do it until you get better at it. Do it until it doesn't hurt so much. Do it until you get so good at it that it doesn't hurt at all. And that's exactly what we did. You see, we built these DevOps pipelines. We pressed deploy, and guess what? Yes, things broke. Everything broke. But that's okay, because we fixed it, and we tried again. And yes, it broke again. But slowly, little by little, over time, we got better. Until eventually, like today, we can actually press that deploy button, and we know our deployments are going to work. It doesn't hurt anymore. In fact, we have confidence now that we never had before. And this actually reminds me of a quote I once heard. Beginners practice until they get it right. Experts practice until they can't get it wrong. There's also a saying in our industry, don't deploy on Fridays. But because we did it until it stopped hurting, this is why we don't worry about what day of the week we deploy on. Monday, Friday, holiday, it doesn't matter. It doesn't hurt anymore. We become experts at it. And we have confidence in the process that we built because they're built on a firm foundation of DevOps best practices. Now, Microsoft, our DevOps story, begins when we first started, right? Microsoft came around in the 80s, the 90s, the early 2000s, and honestly, we kind of dominated, right? But as we just talked about, the way we did things was very interesting. You see, we would deploy out new code, a new product, every 3 to 4 years. That's why, if you think about it, every 3 to 4 years, there was a new version of Windows, or a new version of Office, or SharePoint, or even a new version of what was once called Team Foundation Server, what is now Azure DevOps Server. And honestly, that worked great for us back then. We were very waterfall-like, but the world started moving much quicker, especially around the 2010 to 2012 timeframe. And we knew that we had to make changes, more than just accepting that we have to do what hurts. We had to start making changes with our people, with our org charts. And here's why. Now, if you look at this, yes, it's funny. I actually think it's hilarious. And yes, it is a joke. But as it goes with most jokes, there's actually some grain of truth to this. You see, if you look at how Microsoft is organized in this cartoon, it has all these little silos, or really big silos, right? And each silo had all these hierarchies in them. Each hierarchy or each silo would represent a product group, okay? You'd have the Windows team, you'd have the Office team, the SharePoint team, the TFS, or Team Foundation Servers team. We had all these different teams, but they were all silos to themselves because each team got to decide independently exactly how they wanted to be structured, how they were going to function, and each one of these teams had these almost fictional guns pointed at each other because we were so incredibly passionate about how we did things within our little silos. We actually became hyper competitive against each other. And as a result, we created this toxic competitive culture because we believed that by competing against each other, by the time our products would get out to the public, would get out into production, the product would actually be forged in fire, which would make it better than any previous version that ever existed. Now, back when we were doing deployments every 3 to 4 years, that process and that organizational setup actually worked out okay for us. However, if you're trying to move quickly and you're constantly fighting against each other and you're not collaborating, it turns out you're working against the grain. And therefore, you're actually the exact opposite of the definition of agile. You see, to really be successful at DevOps, it actually starts with people. Remember? Union of people and process. You have to be able to collaborate. You have to be able to work across teams. And you have to do so constantly. You have to get rid of the silos. So this was a huge blocker for us. Now, luckily, around that same time frame, we got a brand new CEO, Satya, and he helped us shift left in our mindset. In fact, he pointed out that our past behaviors and processes and practices may have worked great before us, but that we couldn't continue down this path, especially one that was so toxic, and expect the same results. He created what was called the One Microsoft Initiative, where we are one company, where we all work together and we all try to be successful, no matter what it takes. He also had the idea that we should have one engineering system. And by that, I mean our build systems, our release systems, our source control systems, our tools, and so on and so forth. And you see, this was actually a big change for us because back in the day, back in our little silos, each team could pick whatever tools we wanted to use, which meant we all used different tools. There wasn't a standardized set of tooling or practices or processes in place across all our different teams, which honestly meant it was incredibly difficult to collaborate from a global team perspective. And this is a little embarrassing, we weren't even using our own tools. This made it incredibly difficult to fix what even hurt for our customers. Satya changed all that. He said no more. He set up a standard for all teams at Microsoft, and he set a requirement that we all use, at the time, Team Foundation Server, or what is now known as Azure DevOps. And that's right, we use Azure DevOps to build Azure DevOps even today. Now, why does this matter? Because by doing what hurt, by repeatedly trying these new things, by shifting left in our mindset, by implementing all of these changes, we actually became faster and more powerful than we ever could have imagined. You see, where we once were terrified of pushing that deployment button, today we do an average of 163,000 deployments per day. In fact, we have 6.3 million builds per month. We run 500 million test executions per day. And we have over 96,000 engineers using Azure DevOps, collaborating around the world confidently together. So what's actually the point of this entire story, right? Might sound like I'm rambling on, but actually I'm so glad you asked. You see, as developers who are passionate about what we do and what we create, it's very easy to get put off by a change in tooling, to actually get hung up on the tools themselves. But being told that we're now going to have a standardized set of tools that we may not be comfortable with is very off-putting. But one of the biggest lessons we at Microsoft learned is this. It's not about the tools. It never was, it never will be. It's about the people and the process and the foundation both are built upon. Remember, as the people involved, right? Us, the developers, the engineers, the operations, we all have the same goal. We all want to deliver something of value to our customers, to our end users. And if you're anything like me, you probably want to have confidence in that value regardless of your application architecture, be it monolith or cloud native, abstracted APIs. Now, I want to show you one of the ways you can add a dash of confidence to your development process and even add a bit of inclusion to it as well. I want to show you how regardless of what tool or what system you use, the standardized set of processes, the DevOps best practices, do not change. Let's talk about something called Bridge to Kubernetes. Now, truth be told, full disclosure, this is actually a Visual Studio Code extension, and it allows developers to iterate rapidly and confidently by enabling local debugging for abstracted applications. But I really encourage you to stay tuned until the end of this demo because, spoiler alert, it's not about Visual Studio Code at all. It's not even about the local developer experience. Instead, this is about shifting left in your mindset. This is about thinking how you can apply these confidence principles and DevOps best practices to your process, regardless of which CI/CD solution you use. This is big picture, and this is real world. Let's check it out. All right, so I'm currently within my application here that we're going to use, which is a bike sharing application. It's kind of perfect, right? Because we're all in quarantine, we're all in the middle of a pandemic, we can't do anything with a lot of people, but we can do things for our mental health, our physical health, our emotional health, and we can go on bike rides. So I'm going to use this AdventureWorks Cycles to see if I can rent a bicycle for the day. I'm going to log in as a test user called Aurelia Briggs. Okay, and this application is running in Azure Kubernetes service. It is an abstracted application, so each API is broken out. There's multiple languages going on here, but it turns out that there's actually a bug in this application. For me personally, and probably as most shoppers, we want to take a look at what we're purchasing, right? What we're renting. We're going to want to be able to see it. So if I select this top women's cruiser here, I want to be able to look at the bike, but it seems that I can't. Now, just to make sure that it's not specific to this one item, let's take a look at maybe this women's cruiser. And I still can't see the image. Now, just to make sure again, we're gonna do one more test. We'll click on this bottom men's racing bike, and I still can't see the image. So it appears that we do have a bug in one particular API in this larger application. Now, how would we troubleshoot this? How would we have confidence in what we're debugging, even in the context of a full application? We're gonna use Bridge to Kubernetes to do that. So let's head over to Visual Studio Code here. And I've already installed the extension Bridge to Kubernetes. You would just find that in the marketplace, go and search for Bridge to Kubernetes. You can see that I already have it installed, and that's really all you have to do. Once you have it installed, you'll probably want to configure it. And so you bring up your command palette, which if you're on a Mac is Command-Shift-P, or Windows would be Control-Shift-P. And you could start typing in Bridge, do Bridge to Kubernetes configure. And from there, it's going to ask you which service you want to redirect to your machine. Now, since this is redirecting over to Kubernetes that's running in a cloud somewhere, you're going to want to make sure that you have access on your local machine to that Kubernetes cluster and to the namespace you're working in. I'm going to go ahead and choose the service that I want to redirect, which is the bike service. I know that this is where that bug lives. So I'm going to select bikes. Now, the bikes API is written in Node, and this is just a standard port that the Node application listens on for port 3000. And so that's going to be the local port that I'm going to use for traffic redirection, okay? I'll hit enter. Now I'm going to use an existing debugger. This is the same debugger I would use locally if I were just debugging that one single component without having the other APIs to interact with. So I'm going to select launch via NPM because that's the name of my existing debug process. Now this last question is the most important question. Do I want to redirect all incoming requests to my machine, including those that are also on my development team? The answer is no, you probably never want to do that. But you do want to redirect requests from a subdomain. And this is going to require header propagation. So you'd have to make sure that your application supports that. But this is going to give me as a developer an isolated sandbox environment where I can debug in my own time, in my own space, and have confidence in whatever fix I am able to implement. So I'm going to go ahead and say yes. And you'll notice that it's giving me a suggested subdomain prefix, Jessica D E554. You can always change that later on because once you go through that configuration, it actually adds files to a VS Code folder in your working directory. You can see that I have a launch JSON, which gives me an additional debug process called launch via NPM with Kubernetes. And there's a pre-launch task that's now happening. This bottom one, lines 19 through 27, was my existing just normal NPM debugger. So if I go over to my tasks JSON file, now you'll see here's where I'm calling that Bridge to Kubernetes service, that task, the service for bikes, the port, everything we just filled out in that GUI interface helper. And here's my isolate as prefix that I could go ahead and change if I wanted to. For the sake of time and for the sake of the demo, we're just going to leave it as it is today. And you'll also see that we have a charts folder in here, a Docker file. We're not going to touch it because everything we're going to do is just touching the Node application, and it's just going to be debugging exactly as we would if this weren't even a containerized application. So I'm going to go ahead and actually just start the debugger here. You'll see I now have two processes, launch via NPM with Kubernetes and launch via NPM. So I'll go ahead and click start for making sure that I'm using Kubernetes. And you can see that now the task is starting, right? It's redirecting the Kubernetes service bikes over to my machine. It's making sure that it's targeting the service name, the port, and it's isolating that service. Now, anything else that needs to happen, be it routing, IP addresses, updating pods and updating paths and all that stuff is going to happen all from within this extension. And it's actually happening outside of VS Code. It's happening in the cluster itself from a pod that's living there, okay? So there's a pod called Routing Manager. It uses Envoy. All of this stuff is happening on the back end. But as a developer, it's seamless to you. It's seamless. I didn't have to worry about anything. You can see all these other services got routed to 127.x.x.x IP addresses. All of that was taken care of, and now I'm able to go debug as I normally would. I have access to variables, watch lists, call stacks, all of that. So I'll go back over to my files, and I'm going to open my JavaScript file here. And I'm going to scroll down to find the GET request, right? This seems to happen when we're getting a bike. So we'll scroll down, and I believe it's on Yep, right in here is line 211 is where we start that GET request. If I scroll all the way down, I'm going to set a breakpoint right here on the request to actually send me the bike variable, okay? Now, I can actually, from within VS Code, click Kubernetes down here at the bottom. This is one of the benefits that that extension gives me. I can select that, and now I'm able to go to an isolated instance of that same bike application we just saw. So I'll click on my isolated instance, and now I'm in my own little private sandbox. So I can click on Aurelia Briggs again. We'll click on this women's cruiser. I do like the one with the purple frame and orange tires. But that doesn't matter because I'm in a debug session. I now hit my breakpoint live. In fact, because I'm debugging, if I hover over that variable, I actually get the IntelliSense that I'm expecting to get. And I can see right here that the issue seems to be that we have a static image that's hard-coded for this GET request. So for the sake of time, this isn't about debugging or how to be a developer. We're going to go ahead and uncomment this hard-coded image request right here, image variable. We're going to go ahead and save that. And we're going to restart our debugger, okay? This is really more about how we can add confidence to our process, right? Now I'll go back over to Chrome, and we're just going to refresh the page here. We should hit our breakpoint again. And now when I hover over that variable, I can see that I'm getting a proper image URL. So let's go ahead and remove the breakpoint. We'll refresh our debugger one more time. Let's go back over to Chrome or go back over to our browser here. I'll refresh, and now I should see an image, and I do. And just to make sure that it works on every bike, we'll click around on maybe one or two more bikes. This looks good, and this one looks good. Okay, so this is all great. And as a local developer, I have confidence in that change that I just made. But how do I think bigger? How do I make sure from a collaboration perspective, the rest of my team has the same level of confidence? Easy. We take advantage of CI/CD. So I'm going to go over here to Git, and I'm just going to go ahead and check in this change that I made. I'm going to go ahead and say hard-coded image fix, or fixed hard-coded image. And we're going to go ahead and commit, and then we're going to push. Now, if we take a look at this in our GitHub repo, we'll switch back over to our browser, just refresh here and change our branch over to bike image fix. We can see that yes, that change was just pushed about 15 seconds ago. So we can go over to pull requests, and we'll actually open a new pull request because we have a workflow that's set up on this branch where we can compare our pull request branch or bike image fix over into main. We can see that change that we made. We're gonna go ahead and create. We'll pretend that we entered in all our good, right comments and stuff like good stewards. And you'll notice as soon as we do that, this GitHub Actions workflow is actually gonna fire off. This is all automated. And if we take a look at the details here, anything that we would normally have to do, or anything that we were doing manually or Bridge to Kubernetes in Visual Studio Code was doing, is actually going to happen as part of this GitHub Actions workflow. In fact, it's really easy to maintain because all of these actions are either just running bash commands or they're publicly maintained as part of the GitHub marketplace. And we're able to do all the things that we would normally have to do anyway to test this in a dev test QA canary environment. We're going to log into Azure. We're going to set up any PR environment variables. This includes creating a special branch name that meets the same requirements that we would need in Kubernetes, meaning that it doesn't have too many characters in it or improper characters. We're going to log into Docker. We're going to build our Docker image. We're going to set our Kubernetes context. We're going to make sure we're using that valid branch name, and then we're going to install that single Helm chart for that single API that we worked with locally, that bikes API. And after we do that, we're going to add routing labels. And this is where I said that it actually doesn't matter what you're doing in Visual Studio Code because that routing manager that lives in your Kubernetes cluster that uses Envoy is actually looking for labels that get attached to your pod and to your service. And so using those practices, using those principles, we can apply that to our process where we have the routing labels added. We then actually add a dash of confidence at the end and take advantage of those routing labels. So you can see our workflow file if you're curious. This is all public on GitHub. But let's go take a look at our pull request. And you'll notice we have a green check mark. And that GitHub Actions bot, that's that dash of confidence. The same sandbox URL that we could look at locally in our dev system is now actually added as a comment to our pull request, where now anyone involved in this change can click that and go have the same confidence that we as individual and independent developers had, can now all have it on a collaborative basis, regardless of whether or not they speak code. In fact, when I click the women's cruiser, you can see that it works under this PR branch or this PR deployment. If I go back to the main URL, it's still broken. So there aren't any permanent changes that's made whatsoever in production or in dev or in QA. This is just an isolated environment that we're able to take advantage of even in our CI/CD system. Now you might be wondering, all right, this is cool, but you know what? I've actually invested a lot of time in Jenkins, and I don't believe you that it's not about the tool. Can I do the same thing with a different CI/CD tool? I am so glad you asked. Let's do the exact same thing with Jenkins. All right, so I'm back over in Visual Studio Code, and I've already made my commit message. So I'm just gonna click down here at the bottom to go ahead and push this over into, again, still my bike image fix branch in GitHub. So we can go back over to our browser here. You can see here's my Jenkins instance. Nothing has happened yet because I haven't actually opened a pull request. We'll go over to GitHub. You can see that the bike image fix just had a recent push just now. So I'm gonna go ahead and compare and create a pull request. So again, you can see we're comparing our bike image fix over into main. I'll click create. And this time you can see that the Jenkins branch has already started building, but we actually want the pull request one. So if you give it just a moment, here's our PR merge that's also scheduled to start. We can take a look at the file that was changed. We'll see that was still just that single one-liner. Go back over to our conversation. You can see that the Jenkins is running. So let's go over to our Jenkins instance. And I'll actually open Blue Ocean just because it's a little bit prettier so we can kind of see what's going on here. We'll go into our project, which is bike sharing app. And you can see that there's two different builds that are happening. Now, I'm using a declarative pipeline within Jenkins, and I have a library that I maintain so I can reuse my Jenkins pipelines across multiple projects. And I updated that library to also add in a dash of confidence. Now, one of the things that that library does is it actually checks to see if there's a label for PR dash. And if there is, it'll run the deployment out to Kubernetes. If there's not, it's just gonna end at publishing the container over to my private container registry, which also happens to be located in Azure. You could use Quay, you could use Amazon, you could use Google. That doesn't matter. You can see that all of these tasks are running the same. This is the same thing that we did in GitHub Actions, right? We used Helm, we built our Docker image, and we published our Docker image. But we also continued to deploy it out to Kubernetes. We added some routing labels, and we had that dash of confidence. So let's go back over to our actual pull request pipeline that's running. You can see that it's also doing the Helm package, the Docker build, publish container. But because it starts with that PR dash, now it's also doing the deploy to Kubernetes stage. And as a part of that, it'll add the routing labels and we'll have that dash of confidence step. Now, if we go back over to our project here, you can see that all checks completed successfully. You can see that there were two different pipelines that ran, both of which were Jenkins. And just as before, we got the same comment on the pull request here. Now, it is using my name. That has to do with how Jenkins was using the authentication over to GitHub. That can always be changed in production. But notice on how the principles do not change just because the tools do. All right, I hope you enjoyed that demo as much as I did. Now, we all know that there are existing challenges that come in with pull requests, right? You typically have static code diffs. You have people that are only on your team that can understand the context of the changes that you made. There's minimal visibility of the end-to-end impact that this application has. Think visual testing, think user interface. There's all these different challenges that pull requests introduce. But by adding a little bit of confidence, making sure it's built on top of that firm foundation of including the people, right? Having that be the most important, and making sure that you're using that standardized set of practices and processes, you're able to have a flow that is independent of whatever that tool is. Whether it's GitHub Actions, Azure DevOps, Jenkins, Travis, it doesn't matter. And the best part is, not only do you have confidence in this, you now have inclusion, because even people who don't speak code get to be part of the review process, where previously they were left out or didn't understand what was going on. Remember, as we're going through this DevOps journey, the steps you take don't have to be big. They just have to lead you in the right direction. That's Agent Gemma Simmons, Marvel of S.H.I.E.L.D. But I love this quote because you don't have to do something large and grandiose. All you have to do is just make sure you're going in that right direction of continuously delivering value. Finally, thank you so much for hanging out with me today. It was my absolute pleasure to be here. My name is Jessica Dean. You're welcome to connect with me on Instagram, Twitter, and GitHub. There's no relation to James Dean, so my last name has 2 E's. And then finally, thank you very much for your time. It's been a blast.